Hello, everyone. This is Kristen Huber, and on behalf of Elastifile and 451 Research, I would like to welcome you and say thanks for attending today's webcast titled Hybrid Cloud Innovations for Evolving Scientific Computing Requirements. Leading off the discussion today will be Henry Baltazar, who is Research Vice President of Infrastructure at 451 Research. Following Henry will be Jerome McFarland, who is Director of Marketing at Elastifile. And closing today's discussion will be guest speaker Peyton McNully, who is CIO at Hudson Alpha Institute. Just a couple of quick housekeeping items before we get started. Number one, to ask a question, simply type it in the question box on your screen below and we'll get to as many as we can. Number two, the presentation and slides are available for download. And finally, please provide feedback at the end of the webinar. And with that, I'll turn it over to Henry.
Thanks so much, Kristen, and thanks again for all of you to join us today. As Kristen said, my name is Henry Baltzar. I'm responsible for driving infrastructure research at 451 Research with my team, covering storage, networking, servers, and converged infrastructures. For today's topics today, I'm going to be talking first a little bit about what are some of the enterprise storage and infrastructure challenges we're seeing in the market today. After that, we'll be talking a little bit more also about the growing role of hybrid cloud and why we need to start looking at these infrastructures more closely. After that, we're going to go talking a little bit about more recommendations and also discussing some of the new workloads and challenges coming ahead. Within our research, we do a number of end-user interviews, and this particular interview or this particular quote really caught my attention when I saw it because I think this encapsulates a lot of the problems we have today. Beyond the traditional storage problem of capacity management, which the end user here is talking about in terms of repository management and the painful expansions going on there, I think the other key thing we have to remember is customer expectations are through the roof today. They want to have these services faster and faster. And the reason why we're talking a lot about hybrid cloud in particular is hybrid cloud is going to be the future for IT because I don't believe any single organization has a monopoly on innovation. And if your organization wants to be able to have access to all the latest and greatest technologies, it's going to have to be through hybrid cloud technologies. I don't believe on-premise infrastructure is going to go away anytime soon, but it's not going to be the only place where we do innovations. There's also a lot of really interesting cloud innovative services, whether it be GPU services or FPGA services, and also a lot of other microservices in a number of different fields like analytics and machine learning. And those are definitely some of the things we want to have access to as we go forward. The other key aspect that's a big pain point is we need to do more with less, and that's always going to be a big problem. In our most recent survey, data capacity and growth was the top issue that was hurting most of our customers and main thing that they were worried about. I think what's also notable is delivering adequate storage performance is an issue that was a little bit lower on the chart last year, but has really bumped up a couple places into the top 5 looking at this year's survey. The other key aspect to look at is a big reason why we're looking at improving data management and data protection is, as you can see here, 2 of the top 5 are compliance-oriented or reliability-oriented metrics, meaning disaster requirements, and then also meeting compliance, regulatory, and governance requirements. With a host of all these different challenges, I think it's going to force a lot of us to relook at how we manage and deploy our infrastructures. Looking at budgets, the budget news, for the most part, we are expecting to see slight increases in storage budgets in the next year. In our latest survey, on average, respondents said they were going to see a 12.6% increase. That's down from last year, though. The year prior, we saw about a 17% increase. When we talk to them about why it's growing, as you can imagine, a lot of this is being driven mostly by business growth. What was interesting, though, is while it was only a minority of people that said that their budgets were going to shrink or stay flat, what was interesting to me was if you look at the reasons why, the number 2 reason was we're starting to see people moving their spending to public cloud, which to me is also another clear sign that we have to start looking at hybrid architectures going forward. Another key thing, and I think another point to make if you're trying to make the case for doing more innovation is, organizations are also seeing that number, tied for number 2 reason for cutting their storage cost is the innovations they were able to deploy, whether it be deduplication, compression, or any other type of management type of capability that makes things easier and cheaper to manage. Those are going to be huge benefits also, especially if you're seeing a budget crunch. Another key aspect we're looking at is, to me, I think we have to find ways of delivering more value. And one of the key things we're asking about is, hey, what are the things would you like to see integrated with your core infrastructure platforms? To me, the things that really stood out, especially in the context of this webinar, is the ability to have this hybrid cloud capability and workload mobility capability. That was a key requirement for about 29% of respondents. Likewise, we do see people who want to see better application performance management, better control of their infrastructure and the environment, which was a real key need for about a quarter of the respondents. In addition to the other things that you would expect to see, like data management or archiving, which was around 36%. I think a lot of what we're trying to explain in terms of why we want to, I'm just going to build a slide here, why we want to look at reinvigorating these architectures is, with digital transformation, there's a lot of different expectations that people are trying to meet. On the intelligence side, organizations are all hoarding or storing lots and lots of data, and we're not holding that data for data's sake. We might be doing that for compliance sake, but people want to have more value than that. They want to be able to extract business value from that data. They want to be able to process it rapidly when it's available, so they can make sure they're making the right decisions. Also in line with that is the agility aspect that we need to have. We need to have much faster environments so we can take advantage of this new knowledge we have, either to deliver new services or new applications for our end users. And then finally, the other aspect, which I alluded to earlier, was customer centricity and customer expectations. Customers expect to get data quickly. They expect to have reliable resources. Unless we start doing a better job of improving our infrastructures, it's very possible you could wind up being left behind in digital transformation. Next couple sections, we're going to be talking a little bit about cloud. No secret here, but when we look at the survey, when we ran the survey and asked customers about how they envision their infrastructure changing in the next 2 years, right now, as you can imagine, the majority of it, 59%, is still in company-owned or leased data centers, but a lot of the respondents are expecting to see that dropping to about 40%. In contrast, you can see that while 23% of the infrastructure is being used on off-premises or public cloud services or managed environments, that's going to jump up to about 46% in the next 2 years, which is really interesting. Another key aspect to look at, and another area which I think is going to be important, is third-party colocation data centers. That's going to hold steady going into the next 2 years, but I do believe that's going to be an interesting aspect going forward because of what you could potentially do with these colocation data centers to improve your hybrid cloud access. Speaking of hybrid cloud, as you can look at the bottom left-hand side, I think the most important numbers to look at are those two at the bottom, because it basically shows that, for the most part, very few organizations are going to move everything to public cloud or to a SaaS environment. Only 12% of respondents said that. Also, very few people are going to just keep things in an on-premise environment. That was only about 10%. When we look at the future of IT, I think it's going to be a much more broader infrastructure, leveraging both public and private cloud, public and on-premises resources. As you can see in the top, 44% believe it's going to be those two resources together and mixed. There are still 17% of respondents who think they're going to use public cloud and on-premises resources, but don't want to mix them together. And when we start digging deeper into why people are hesitant about that, we start looking at why they don't like cloud. And there are still definitely concerns that are preventing some organizations from adopting cloud, whether it be security concerns or also issues like data locality and sovereignty. Another key issue to keep in mind is cost. While cloud is a very powerful tool because it's elastic, we have to remember everything you use comes with a price. It's not just the capacity pricing that you pay on a monthly basis. You also have to think about bandwidth charges if you're going to be pulling data out of a cloud, because most cloud providers have bandwidth charges for egress fees. Ingress is usually free because they want you to put the data there, but pulling it out usually costs you money. That's something you have to keep in mind. The other thing to keep in mind is as you start using flash-based storage resources or other high-performance resources, you're going to have to pay for that as well. Yeah, and I think the other key aspect that a lot of our end users are afraid of is they see that it's easy to move data into cloud, and they see that the cloud providers want them to keep them there, but a lot of people are afraid of how they're going to deal with the exit, how that's going to be exorbitant, just as this end user has pointed out. And this really is seen pretty closely when we look at the survey results. Right now, very few, a small percentage of customers have actually moved data out of cloud. 66% of respondents in our recent survey said they've never done it. For those that have, the majority of them are moving it either to a hosted private cloud environment or an on-premise private cloud environment. But what's also interesting to see is why are they moving it out of cloud? What are they not getting at cloud that's forcing them to look at these new architectures? And again, what was interesting to find was the top reason for them moving was performance and availability issues, which shows that not everything is going to be able to be done in a public cloud. I think there's going to be opportunities to innovate on both sides, but the key thing is you want to make sure you can hedge your bets. You can hedge your bets. You want to make sure that you can tap into all the resources that are available to you. Sorry, trying to get to the next slide. The other key aspect is a change in what's going on with in terms of cloud services. Right now, the majority of services today are being used primarily for cloud-based storage for cloud-based applications, but we're seeing that starting to decline in terms of being the top reason. A lot of other organizations are starting to look at cloud also in terms of backup, disaster recovery, file signature, and other types of data management. I think that's going to be really important because as more of this data goes into the cloud, I think that's going to provide more abilities for you to take advantage of that data in the cloud and take advantage of cloud innovation. So as new services come online, whether they be text analytics services or other things like that, you'll be able to tap into that innovation and make sure you can use that with your data. The other key aspect that we're looking at really closely is cloud-based NAS. Right now, that's only about 10% of respondents using it today, but we're expecting that to double in the next 2 years. There's another cautionary tale. When we started looking at these environments, a lot of people are rushing to get from on-premises to cloud, but as you can see, sometimes if you get to cloud, you may not find it is exactly what you expected. And it does make sense to make sure you're looking at the complexity associated with your on-prem environment and how you can potentially improve it before you wind up doing a wholesale migration out. In terms of recommendations, I definitely believe the cloud NAS area is going to be a key area to keep following going forward. Cloud NAS, right now when you talk about cloud storage, most of the talk is around block storage or it's around object storage. But the fact of the matter is most applications don't speak object storage, especially a lot of the applications that you have written in your own environments and may want to take to the cloud. That's going to be a drawback if you're trying to move those type of applications. So I think that's why we're going to start seeing more cloud file services being enabled. I think Cloud NAS is going to be really important not only for simplifying that data sharing between applications and end users, but again also allowing the legacy applications that you don't want to rewrite for object to be able to run in these cloud environments. I think the other key aspect of this is the elastic storage capability that comes with that and scalable performance capabilities. I think those are really key things, and I think those are key aspects that are going to be highlighted as we talk about this from a scientific computing standpoint with Jerome and Hudson Alpha. I think the other key aspect we're worried about is data doesn't live just in the central data center. We need to be able to have remote access to be able to capture that data and leverage that data in other sites beyond the centralized data center and also beyond the cloud repository itself. I think the other point I want to make is, as we start looking at cloud archive services and other cheaper ways of storing data, those are also going to be really important for you long term because if data is in the cloud, that also means you may be able to share that data more easily with other partners and other customers that are also in the same cloud. The other thing to keep in mind is while the focus of today is definitely is going to be on scientific computing, I think there's going to be a number of key emerging technologies to watch out for, which will have similar problem sets and where you could probably learn. I think a lot of what we're doing, what the innovators are doing in scientific computing today are going to be applied to a lot of these technologies that we're expecting to see expansion in the next couple of years. In terms of the top things right now, we're expecting to see big data processing increasing importance. We're expecting to see business intelligence. Also, key aspects like machine learning and artificial intelligence. The thing I noticed, if you're looking at this chart, the right-hand side, the brown bar is in use. And while there's definitely a lot of interest in doing these things, if you take a technology like machine learning and artificial intelligence, in our most recent survey, only 12% of people have done it. So don't feel left out if you're not doing it yet. A lot of your peers are not doing it. But the thing is, the time to prepare for that is now. And I think because of these emerging technologies and what we have to go forward, and also the existing challenges in the enterprises, now is a great time to start thinking about how you're going to make your hybrid environments more powerful. And with that, I'm going to kick things over to Jerome.
All right. Thanks a lot, Henry. Again, I'm Jerome McFarland, Director of Marketing at Elastifile. And just to start things off, just going to give you a quick primer on Elastifile and kind of who we are. So Elastifile was founded by industry veterans with deep experience and expertise in software-defined infrastructure, application optimization, virtualization, and flash storage as well. And what they really saw was an emerging need for solutions that could really unleash the power of hybrid clouds. And so they set out to solve for those associated challenges. We've been backed by some industry leaders in the enterprise cloud data center and flash storage arenas, and we've been honored to have our vision and solution validated by some recent recognition within the industry, as you can see here with the examples from Gartner and from CRN. Now, the solution that we designed, it was created and designed to solve the data-centric challenges, data-centric problems that are holding back data management in the cloud and across hybrid clouds. And we really see that problem space as being separated into two major challenges. And the first one of those challenges is that on-premises IT has been struggling to achieve cloud-like efficiency. Right? Enterprises and research institutions, they really want to leverage the benefits of public cloud infrastructure. Benefits like elastic scalability, like freedom from hardware lock-in, benefits like consumption-based pricing. They want all those benefits, but they need to leverage them within an infrastructure ecosystem that includes their on-premises environments. The second challenge is an inability to lift and shift applications to the public cloud. Right? There's a world of existing applications out there that can benefit from the scalability and elasticity of cloud infrastructure. But however, to deliver those benefits, organizations, they need ways to run those apps in the cloud without having to refactor them. And they also need to ensure that those apps and the associated workflows can meet the performance and the availability SLAs that they're expecting of them. And finally, they also need to deliver the benefits of the cloud in a cost-effective fashion, both when they move data to and from the cloud and when they're managing data within the cloud. And so the Elastifile solution was designed and developed to address these key data-centric challenges. And at the heart of our solution, which we refer to as a cross-cloud data fabric, there are two key components, as you can see here. And the first key component on the left is the Elastifile Cloud File System. This is a scalable, enterprise-grade, POSIX-compliant shared file system that we designed from scratch to support the needs of cloud-integrated workflows. Our file system is fully software-defined, so there's no dependence on specific underlying hardware. So this enables us to run it in the cloud, to run it on-premises, or to run our file system in both locations simultaneously. Right? All the while presenting a standard POSIX interface that ensures compatibility with both those pre-existing traditional applications and also with more recently developed modern apps and workflows. And also to make sure that we support the specific challenges presented by data-intensive workflows, like those found in this realm of scientific computing, we designed our file system to deliver best-in-class performance and scalability, with performance increasing linearly as the file system infrastructure is expanded. So this linear scalability, coupled with the software-defined design model that I discussed before, this allows customers to elastically adjust the capacity and the performance of an Elastifile cluster to ensure a really cost-effective alignment between their workflow requirements and the amount of infrastructure that they have deployed at any given point in time. So being really able to right-size that infrastructure for their needs. The second key component of our solution is Elastifile Cloud Connect. Cloud Connect enables a granular bidirectional data tiering between any POSIX file system and object storage. So when leveraged for hybrid cloud deployments, Cloud Connect allows you to efficiently load data from an on-premises file system into object storage in the cloud. And like I mentioned, it's any on-premises file system, right? It doesn't necessarily need to be Elastifile. It could be NetApp, it could be Isilon, it could be whomever. Our goal is really just to make it easy for customers to integrate cloud infrastructure without requiring a really painful on-premises rip and replace. Now, if you leverage Cloud Connect in the cloud, that file-to-object tiering, now we're enabling cost-optimized data tiering between object storage in the public cloud and an Elastifile file system running in the cloud. And this allows data to reside in the most efficient, cost-effective location at all times. So data can be loaded into the Elastifile file system when needed for active processing, and it can remain within cheap and deep object storage when it's inactive or when it's cold. So the combination of these two key components, the file system and the Cloud Connect file and object data tiering, is what we call the cross-cloud data fabric when you put all the pieces together. And we see this as an extremely practical solution that can support customers who may be in various different phases of their cloud journeys. And I've really found that the best way to emphasize the power and kind of the practical nature of our solution is to walk through an example of a typical customer journey as they leverage Elastifile to integrate cloud infrastructure. So as I mentioned before, our file system is fully software-defined and hardware-agnostic. So for customers who are starting on-premises, they can leverage cost-effective standard servers and storage devices, and our software will unify the available storage capacity into a single namespace. So the IT organization gets the benefits of cost-effective scalable hardware, and the applications get to interface with a POSIX file system just as if they were running on a traditional NAS array. Now, when an organization is ready to take their first steps into the cloud, Cloud Connect allows them to efficiently transfer data to object storage. To optimize performance and minimize costs, our Cloud Connect capability ensures that the data has been compressed and deduped before transfer, and then we only send the changes to data after the initial data synchronization. And also, when we store the data in object format, we retain all the file and directory hierarchy information as well as versioning information. And data can be shifted back and forth between file and object as needed. And again, since Cloud Connect can tier data between, from any on-premises file system, a cost-effective hybrid cloud can be implemented while still extracting value from an organization's pre-existing on-premises storage infrastructure. And for a customer who may be starting their journey into the cloud with a simple backup, archival or DR type use case, they might stop, right there. But things really start to get more interesting, however, when a customer is ready to start leveraging the cloud infrastructure for active data processing. At any time, you can spin up a scalable Elastifile file system in the cloud and use Cloud Connect to load the desired data from object storage, thus leveraging our file system as the enterprise-grade storage platform for in-cloud data processing. So in some cases, a customer may simply leverage, cloud scalability to apply, massive compute power and accelerate some time-sensitive processing job, right? Just throwing lots of CPUs at some job that they want to complete more quickly. But in other cases, they might be leveraging the public cloud to apply specialized services. For example, they might be leveraging printable VMs or spot instances or GPUs or even TPUs for machine learning. So when a customer has leveraged Elastifile for active data processing and they complete whatever job that they're executing, those results or the solution or the answers, they can be pushed then back into object storage. And with the results located safely in object storage, when the customer is done with their processing, they can then tear down the in-cloud file system infrastructure, thus ensuring that they're really only paying for the cloud infrastructure that they actually need, and they're only paying for it when they actually need it, right? So again, really highlighting the ability to be very cost-effective and have a very practical way to implement hybrid cloud workflows. And so this dynamic ability to spin up and spin down file infrastructure, it's a great fit for cloud bursting use cases. And a really interesting and nice example of that is one of our customers named Silicon Therapeutics. They're leveraging Elastifile to burst some really data-intensive molecular dynamics workflows into Google Cloud for drug discovery. And their multi-stage workflows, they really require scalable capacity, they need file sharing, and they need high performance for data access and ingest. And enabling them to run on standard POSIX infrastructure within Google Cloud allows them to leverage the advantages of preemptible VMs and Google GPUs, which they need for their workflows to accelerate them. If you're interested in learning more about that specific use case and workflow, you can read more about it in a recent blog that was published on the Google Cloud website. So moving along in our flow, we also have asynchronous replication capability for customers with workloads that require direct synchronization between two file systems, right? This would be skipping the object tiering step. And again, here we're just providing flexibility to support an assortment of workflows and use cases based on a given customer's requirements. And so thus far, I've really focused and presented the on-prem to cloud connectivity in the one-to-one fashion, but it's really important to point out that our Cloud Connect capability also facilitates data transfer between multiple on-prem sites and multiple clouds. Now, when designing multi-cloud architectures, what we've seen is that from a practical perspective, most organizations seem to prefer a hub and spoke model, where an on-prem location would serve as the hub, and the public clouds that they want to leverage would be at the end of the spokes. And with this type of architecture, they can leverage Cloud Connect to sync data to cheap and deep object in the clouds of their choice, and then they can spin up our Elastifile file system in whichever public cloud infrastructure that they want to leverage. And again, that choice could be based on the current costs, or it could be based on the need to leverage cloud-specific features. Then when processing is done, they can minimize cloud egress charges by only bringing results back to their on-premises location. And of course, Cloud Connect will still do its deduplication, its compression, and its diff checking to minimize the size of the data transferred, thereby reducing costs even further. And finally, I should also mention that Cloud Connect enables connectivity to private cloud infrastructure as well. Our bidirectional file-to-object tiering is also fully compatible with S3 and Swift-based object storage appliances. And finally, really just to summarize, by delivering this kind of practical solution for cloud integration and to enable hybrid clouds, what we're really doing is enabling a broad range of data-centric workflows across a variety of use cases and verticals, including genomics, semiconductor verification, seismic processing, machine learning, and many others. And so we see this as a really practical solution and a way to implement cloud connectivity and hybrid cloud workflows in a way that previously hasn't been possible. And so with that, I'll now pass the baton over to Peyton from Hudson Alpha.
All right, thank you. And I think in kind of jumping from the Elastifile aspects and the nuanced details of tactically how it plays out in an environment that is hybrid, and then also playing off of Henry's market dynamic of who all is going hybrid, I wanted to kind of talk about how hybrid is certainly rough around the edges, and kind of share some of the war stories, but then also some of the successes as we see it from Hudson Alpha. And so to give a little context for Hudson Alpha was founded by these two gentlemen, Jim Hudson and Lonnie McMillan, industry pioneers, and they were looking for to build a place that was a nonprofit research institute that had entrepreneurs, educators, clinicians, and researchers all collaborating together in this field called genomics. And so they built this place on a 150-acre campus at our headquarters there in Huntsville, Alabama. And we're unique in that there's not only the research aspects that are occurring at Hudson Alpha, but there's also 40 or so associate company tenants that are also engaged in work in this field there at our facility. And we've heard a lot about hybrid cloud. We've heard a lot about cloud specifically, and I think it's incumbent on me in talking about research computing to kind of dispel some rumors. I personally feel that research computing has always been the cloudiest of the field of high performance computing. In that we've always had these central tenets of cloud where it's been a shared pool. There are empowered users that are able to shift and change apps and workloads and even architectures based on their needs. And it's always generally measured in this temporal measure of X number of core hours, Y number of teraflops, et cetera. But I think I wanted to also kind of dispel the rumor that research computing, I think, has gotten a bad rap as being this stalled car on the side of the highway while everyone else runs headlong into a public cloud environment. And that's not to say that cloud-first strategies are bad. It is to say that I think, in general, each organization has its own culture and its own dynamics that it has to take into account for as they move cloudward. And so kind of fleshing out this idea of the edge of clouds, and there's all sorts of really probably cheesy analogies about clouds and storms and that sort of thing when they collide. But I do want to hone in on the edge becomes more apparent in your strategy as you hit an exponential curve of anything. And this is actually I think it's a kind of humorous graphic from a Google presentation recently where, in the exponential chaos, you actually have amazement that the thing that you just built from an IT or a technology standpoint is actually working. But then also when you don't hit your curve and you essentially pre-position a bunch of assets because you were trying to be proactive IT, there's this disappointment of, oh, we have too much. And so I think for us and how we view it, the edge of clouds are where public cloud providers want you to never, ever leave. And so they do things like egress fees that you may have a good model around, you may not. And, it's not convenient to really learn every possible public cloud provider's nuanced API. There are all sorts of maybe on-prem dependencies or specific vendor tool sets that they're currently locked into. And then there's really just this speed component that I think we as IT have not done a good job with respect to supporting our end users, that we're trying to always do better with. There's Jerome mentioned the lift and shift piece of it. Sometimes lifting and shifting of 4 to 6 petabyte of data is not really feasible in its entirety. And so I think the point of this is to really say that most things in your hybrid approach are going to break at the edges of your approach. And that is, I don't believe there is a right answer for every possible scenario in one solid public cloud provider to choose. And so that's why you need to be hybrid. And so the case study I'll give is a kind of a genomics as a service example, which is Sean Levy's group, the Genomic Services Lab at Hudson Alpha, is guilty of producing this 6 to 8 petabyte of new data per year. And it's incumbent on us in supporting that endeavor to provide them this magic as a service stack. And that's really what they're providing their end users, is the ability to drop off a sample, to do a whole bunch of genomic sequencing and deliver this data. And so as we build out our hybrid approach, they need to be able to scale up, scale down, and do all the things that maybe in an on-prem environment they can do, but also leverage a lot of the great resources that are available in public clouds and be nimble enough and verbal enough in understanding of what's out there and what's available and what they need to leverage. And so in kind of walking through that case a little bit more, there's the actual process that I wanted to highlight that the Genomic Services Lab is actually engaged in. So they take in samples, they're going to sequence them, they're going to do several different types of processing as part of that deliverable, but they're going to use drastically different platforms depending on what their end result is. And so if you think of that previous graphic with the magic as a service, there's high I/O requirement. There may be some FPGA accelerators that need to be leveraged. There could be some GPUs for either rendering or for machine learning models. And then also, as Jerome mentioned, the requirement for cheap and deep storage for that 6 to 8 petabyte of new data per year. So that's really the context for talking about orchestration as the real benefit of a hybrid strategy, is that essentially we need to be good stewards of obviously the resources that we have as a nonprofit, but we also need to be able to functionally get the data in the right place. It needs to be accessible, durable, and timely across all these clouds based on where our end users are going to need it. It needs to be secure. There are as many different data sovereignty or data handling agreements in place as there are sequencing entities that we're working with, and then also we need the apps to be available and run in the best location for that app. Not every instance do we have a hammer in our hand and need to call it a nail. Sometimes we need to burst up cloudward. And so what I would say is, in hybrid orchestration, of the data, we become more efficient as opposed to locked into a central, this is your one opportunity to use the cloud, and so go forth and do great things. And so our orchestration is about navigating those common and uncommon denominators across all these clouds. And to make that make a little bit more sense, we've mentioned the single namespace and the availability to archive cheap and deep into any of these public cloud environments, but also into a private cloud environment. And so there are instances where I mentioned FPGAs. And so if one of our researchers or associate companies or someone that we're collaborating with is interested in using an FPGA on a by the hour type of agreement, then congratulations, they just selected to use AWS. That's where you get FPGAs in that temporal time measure. And so by that same token, if they are wanting to do a latest and greatest machine learning model leveraging TPUs, then congratulations, they've just selected GCP, and we need to be able to assist them in moving that data in so they can run their training model and lift and shift into that environment. The flip side of that is that there are obvious great reasons and rationale when you're producing at an exponential curve, and it's the exponents are kicking in at 8 to 18 month intervals. There's a lot of existing investment in on-prem capabilities and resources that we're still able to leverage and become more cloud-like as an IT organization. That's our end state. That's not to say that we've arrived and we are super duper cloud-like. We think we started from a great base of being flexible and nimble. We know we have to speed up. We know we have to engage more with the data and where the data is and how the data is accessed. And so this is kind of our approach to mitigating the bad pieces of each cloud. Obviously, we've talked egress fees, but some of that is just a function of speed or not having a specific platform, and then really maximizing the good in each of these cloud-like environments to include our own cloud on-prem to functionally make a really, really big cloud is my kind of elementary summary of where we're progressing to. So that all seems really easy is kind of my jab at this, but I think it's certainly incumbent on us as an IT organization to select the right partners and the right approaches to afford us that new flexibility and really engage at the orchestration layer with our data. So my summary is quite simple. We kind of broke our first attempt at cloud because we didn't really take into context the necessity for lifting and shifting data as it sits today, and really our end users are not just expecting it, but I think insisting that we really begin to take their data as it sits into account, and if we don't give them a pathway to a new, better horizon, then I think we're failing in our job as an organization. And so the hybrid orchestration across the many clouds is really where we think we gain security, we gain higher fidelity applications because we're using the right tool for the job. And then we also potentially, even as a nonprofit, gain some opportunity to save money and be more efficient with these resources. And so that's our summary of kind of where we took it in that case. And I really appreciate everyone taking the time to join us today.
Thanks a lot, Peyton. That was great. There's definitely a lot of key points there, and it's interesting. And I'm glad that some of the issues you're seeing are actually some of the problems we're seeing with our customers as well. Even though they may not be scientific computing type environments, most of them are not scientific computing environments. So it does show that a lot of these problems are universal, and I think it's really interesting. Even if you're not a scientific computing person, I think most organizations are going to be faced with these CPU and innovation challenges. So it's going to be important for us to do a better job with hybrid cloud. I've got a couple of questions that I'm curious to dive a little bit deeper into. For Payton, I'm curious, at this point, as you develop your hybrid and multi-cloud strategies, has the cloud egress charge become a concern? I know you mentioned that a little bit during the presentation, but I'm curious to see how do you plan around that, and what are you seeing to help mitigate those charges?
Yeah, so I would say the inability to really place a budget number on a specific unit of work is always a challenge in any organization, regardless of what you're doing. And so you mentioned research computing versus elsewhere in industry. I think that is a pain point in and of itself, but I think also being able to characterize for us the way around that has been being able to characterize the workload type as, let's call it a map reduce. And so if a lot of data in, I'm only going to pull a little bit of data out, then it's probably a great approach to specifically putting it in a public cloud environment. The flip side of that is that some of the whole cottage industries have come about of handing somebody the keys. I'll get all the data there, and then I'm going to give you the keys, and you're going to be responsible now for paying to take it wherever you're going. And so I think that is obviously another instance of it.
Okay. I'm also curious, have in your deployments, because the other thing I was impressed with is the wide breadth of different features and technologies you're using. I'm curious, but as you've looked at these, have you encountered any sticker shock at all in your organization towards the hybrid cloud? Is there anything regarding cloud services that was more expensive than your team expected?
Yeah, so I think there's once you total out the short answer is yes. I think the acceleration of egress and paying so that you can get your data faster is, I think, one instance where we did have a little bit of sticker shock in actually moving data down and out on a DR use case specifically. But I think the flip side of that is that if you're progressing from a small test case into a larger production environment, I think you're fairly well assured that to limit the opportunities for sticker shock in carefully choreographed and orchestrated workload types. And so we've been able to mitigate most, but there have been opportunities where we were surprised.
Okay, great. I had a question for Jerome here. So on the Elastify side, are you providing hooks or features to help egress fees or minimization of the cloud infrastructure costs?
Yeah, definitely for sure. Our solution really was architected and designed to minimize the infrastructure costs for the customer, the user, from end to end. And probably there's two key areas worth kind of pointing out and highlighting in that arena. One, as I discussed a little bit in the presentation, when we ship data leveraging Cloud Connect between file and object, between on-prem and the cloud, we make sure we compress, we deduplicate, and we only send the deltas from the most recent sync. And that's not only for, speed and efficiency of transfer, but it's also for cost reduction, right? Because all those things reduce the data set size and minimizes the inbound and outbound WAN costs and minimizes egress charges when you're talking about, bringing data back from the cloud. And also that ability that I described when you're in the cloud environment to dynamically spin up and tear down our infrastructure on demand, that also enables users to really just pay only for the infrastructure that they really need. So yes, with the egress fees, we're definitely doing things around that, but also more generally, we've designed the solution to allow customers to really match their infrastructure costs at any given point in time to what they only actually need at that point in time.
Okay, that's interesting. Another quick question here. Looking at this, obviously there's object and file storage in on-prem. File storage is going to increase, I believe, in cloud, and I think a lot of people are seeing that too. But right now, how do you rationalize the importance of file storage with the existence of cloud-native apps that interface directly with object storage today?
Yeah, I mean, we see file and object happily coexisting for the foreseeable future, right? It's definitely true that some apps are being rewritten for object storage, and that's just fine, if an organization has the resources to do that. But it's also true that the vast majority of existing apps were written for file systems. And it's also true that most customers don't have the time, the inclination, or the expertise to rewrite their critical applications or custom scripts to interface with object. So that's why it's important to deliver a file interface that looks, smells, tastes, and behaves just like what the application would expect when it was on premises. And so that's what we do. We enable those apps to be dynamically moved from an on-prem environment into the cloud without having to be changed. And so making that kind of hybrid experience much more seamless and painless.
Yeah, I definitely agree there. And that's something we definitely hear in the enterprise and service provider environments. I mean, there's a lot of applications today, and quite frankly, majority of those applications don't speak object storage yet, and it's just too expensive to rewrite those. So I definitely believe we're going to have these types of environments with flexibility. Another question for Jerome. I'm also curious, what other scientific computing environments have shown interest in using Elastafile?
It's really a wide range of applications and workflows, right? Genomics is one example. I talked a little bit about molecular dynamics. In that case, used specifically for drug discovery. Circuit design and simulation is another key area for us because there's some really data-intensive challenges there, especially as you think about circuits getting more and more complex and getting smaller and smaller as they fit into our various shrinking mobile devices and now into IoT devices. Also, the area of machine learning is one where we see a lot of interest and a lot of applicability. So it's really a broad range.
Okay. I was curious. Obviously, the focus today is scientific computing, but it seems like there could be other areas where you could use this technology. Jerome, at this point, can this technology, are you seeing it being used to support mainstream applications, or is this something you really see more for the performance-sensitive verticals?
It's definitely both. There's lots of mainstream apps that customers are leveraging with us, from databases to, WordPress backends. And I think it's because a lot of organizations are really looking to simplify and consolidate the snarl of IT management infrastructure that's evolved over time around their traditional workflows. And so in a lot of cases, by shifting those workflows to the cloud, as enabled by Elastafile, it provides them a great way to do that simplification and consolidation and take the burden, off of on-prem IT and allowing them to focus more on their core business.
Okay, great. And the last segment we want to talk about is I'd like to go a little bit deeper into what we're expecting to see in the future going forward. I got a question here for Peyton. There's a lot of buzz around AI and machine learning these days. How do you see that technology benefiting the healthcare and life sciences domains, if at all?
Yeah, so we have several researchers right now that have been and will continue to build out, fairly specific, but also very powerful frameworks for dealing with genomics data and all sorts of health and life science, electronic health record data. These models are, I think, part of both predicting treatment plans and care in the future, but I think even more interestingly.
Okay. Actually, I should also ask Jerome about that same question. Jerome, in your case, are you seeing artificial intelligence and machine learning as an area where you could find Elastafile delivering value?
Yeah, definitely. It's actually an area where we've been seeing a ton of interest from different organizations, because I think what's been happening is the machine learning ecosystem starts to mature, which is still happening. There's an increasing desire to support more continuous workflows where you could have an organization generating lots of data on premises. Could be images, could be video files, could be anything, and they want to leverage the cloud to do the machine learning training on that data. So they could be generating the data on-prem, then they send the data to the cloud for training and create those trained models. And then now that they have the model, which they've created leveraging the scale-out, powerful compute, possibly TPUs, in the Google Cloud infrastructure. So they got this trained model, and now they want to leverage that model on premises. So they don't need to pull the training data set back, so don't pay those egress charges, but you can bring that trained model back on-prem and then apply the inference process locally to that trained model. So now you can have a kind of flow or an ecosystem where you've got, data coming in, maybe you're recognizing, certain images, and as you increase the corpus of your images, you send those to the cloud to make your model smarter, and then you bring the improved model back on-prem so that you get more accurate analysis and image classification, in real time locally based on the improvements that you made in the cloud. So those kind of continuous hybrid workflows that involve the training as well as the motion of the models from the cloud to on-prem where they'll be leveraged. We've been seeing a lot of interest for that. And our Cloud Connect capability, which allows you to kind of manage the data transfer between environments, as well as our ability to manage unstructured data within our scale-out file system, it's a perfect match. That combination works really well when applied to the ML paradigm.
Yeah, that's a really interesting point. I think the main thing it really harkens back to is I really don't think any one area can claim to have a monopoly on innovation. Innovation is going to come in a lot of different areas, and because you want to be able to have the access to that innovation, I think that's why this hybrid cloud things that we're talking about today, the principles and the benefits are going to be that much more important. Because who knows where the next GPU service or FPGA service or new machine learning microservice is going to come from, and you don't want to miss out on the new technologies because you're too siloed into one area or another. I've got another question here for Peyton in terms of, it was really interesting to hear about some of the advanced things you're doing with cloud services, but Peyton, for your organization, how are the FPGAs being used in the cloud? Do you have similar capabilities for that on-prem as well, or is that the deployment of that technology only in the cloud?
Yeah, good question. So there are and have been previously a few different accelerators for some of this primary and secondary analysis for genomics data that have been available on-prem. Actually, ironically, in a kind of a lease as a service model. And so recently, with the addition of FPGAs in AWS, Edico, to specifically point out one, has offered their service in a public cloud environment as well. And so the ability to use the existing best practice that we enjoy on-prem, off-prem in a public cloud, and then also have the POSIX file system line up and everything converge into a different environment has been beneficial for us as we scale, as we go back and reprocess different items. We're able to give the same experience in a public cloud as we would on-prem. And so that is a fairly new addition, but it is one that is beneficial.
Okay. And, another key area that we're looking at and that it seems to be gathering a lot of interest, especially in these analytics and HPC and scientific computing environments, has been on GPUs. How much of an impact do the GPUs have on the performance of your applications?
Yeah, so specifically on the applications themselves, very little, but I'd say that we're a research organization, and so there's always something new that's being tested and applied and dialed back in. And so I would say that for us as a nonprofit organization, the ability to leverage a latest and greatest GPU cluster anywhere is beneficial to us to kind of dial in and test those new methods. But I would say that it's also quite candidly cost prohibitive for us to go sink into an on-prem gigantic new GPU environment for such a test. And so, really what we're looking to do is, through this hybrid architecture, allow researchers to use X number of tensor cores for whatever time they need, and then give those back so that we can enjoy the consumption-based model for a little while longer and test and retest and then provision the large environment when the economics line up.
Okay, it's really interesting. I was also curious, looking forward for you, Peyton, is there any particular things or innovations or technologies or improvements that you'd like to see for the infrastructure and cloud environments. What are the things that you'd like to see going forward?
So I mean, if it's a blank slate, I haven't used my three wishes yet. I would say, the doing away with egress fees would be amazing, but I don't think that's in anyone's interest right now. But I would say that also, I think the container orchestration is getting there, and I think securing container workloads and app workloads is certainly getting there as well. I think as we get further downstream into large Kubernetes deployments and everything else, I would like to see a better focus on in access management as it pertains to specific data sets. And I think there are a lot of really good pursuits kind of out there in industry. But, we've talked a lot about moving our data to a cloud, and each one of those clouds is going to have its own IAM framework and ACLs to build from. And so I think together as part of the fabric is kind of what's next for us.
Okay, that's actually another Red Hat topic. We've gotten tons of inquiries on container storage in the recent time. Actually, let's ask that question to Jerome. I mean, Jerome, for Elastifile, what do you guys have, or how do you play with containers today?
It's actually a great question. As a POSIX file system, we're the perfect solution for persistent storage for containers, right? Because containers also, as a POSIX shared file system, I should really say, because by leveraging us as the persistence layer for containers, it allows you to share data between containers and also between container pods. And also when you think about leveraging containers as the application mobility vehicle that can allow you to move things from on-prem to the cloud and back, we're the data mobility vehicle that allows you to complement that. And, we have a Kubernetes provisioner that's published on GitHub, so containers is also a story that we integrate with very well.
Yeah, that's going to be a really important issue. If you're not playing with containers today, definitely go look at that, especially with all the cloud technologies that are enabled, and it gives us a great chance to be able to take advantage of those technologies easily. I'd like to thank you all for joining us today, and I'll be kicking things back over to Kristen.
Great. Thank you, Henry. As a quick reminder, the on-demand version of this webcast will be available on BrightTALK shortly. And on behalf of Elastifile and 451 Research, thank you so much for attending today, and have a wonderful day.